Welcome to Coffee, Contractors, and Concrete, a podcast series focusing on all aspects of the surface preparation industry and brought to you by the industry experts at Buy Manufacturers Direct. Joining the podcast today is Substrate Technology President, Industry Patriarch, social media educator, and leading subject matter expert, Josh Jones. So let's move on to the next step. We've taken care, we know we've identified the hardness of our concrete. We've identified the pH levels. We've taken the steps and precautions to take care of that. The next step is we have to create a profile in the concrete. CSP has a 1 through 9 rating. And they also have some identification factors of what mechanical process identifies with specific numbers in their system. Can you touch a little bit on that? What does the 1 through 9 process mean? And real briefly, what mechanical processes would go with that number?
When it comes to the ICRI CSP chips that go 1 through 9, as you said, I'm not versed in anything above a 5. And the reason being is because some of these profiles are for pressurized tanks. So it's for different types of coatings that what I'm familiar with. I can say that 1 through 5 is something that definitely is a more common range that's going to be accessed by contractors as far as the coatings they're installing. CSP1 is a acid etch. CSP2 is a diamond grind. CSP3 is a shot blast. And a CSP4 bush hammer. And CSP5 is a scarification or scarifier. Those are the different concrete profiles that on a daily basis I would be referring to or answering questions about. The majority of the time, though, it's going to be CSP 2, 3, and 4. Those are the most common, I would say, that are utilized or required by thin mill coatings as well as urethane cements and epoxy mortars.
Okay, so let's talk about the surface preparation. There are 2 common methods. There's mechanical, which we've touched on a little bit, and there's chemical. Let's focus right now on mechanical. You've already mentioned a couple of those steps. Let's start with the CSP2, the diamond grind. Generically, what is that, and how would grinding is kind of a big open topic because there's lots of different types of grinders, a lot of different mechanical processes. Just kind of go through mechanical grinding, the difference between say a planetary direct drive and a single disc grinder, and what are the advantages and disadvantages of each of those type of processes?
Well, from the standpoint of the concrete, that we're trying to scratch, a rotary or a planetary is going to scratch the concrete as long as the diamonds are sharp and they're correctly matched to the hardness of the concrete. The result of running the machine and the diamonds over the floor is going to be obvious. The floor is going to go from, let's say, a dark color, whatever it might be, to a much brighter, more chalk-like surface, because the diamonds, regardless of the machine that they're on, are going to scratch or fracture the surface of the sand particles and the cement paste that reside at the top of the concrete. When we normally think of concrete, whether it be hard troweled or broom finished, it's kind of a beige or a gray. When it's ground, it becomes a much chalkier, light colored floor as a result of the scratching. Usually, if a floor has gone over and anything has been missed, that will be noticeable because the areas will still have a different color because the diamonds didn't effectively scratch that layer. But it's the same as sanding wood. It's the same as grinding metal. There will be an obvious result that takes place after the diamonds if they have effectively scratched the surface. That can be on a rotary, or it can be on a planetary. It can be on a monorotational buffing machine. As long as the floor has been scratched by that tool, then it really doesn't matter from the floor standpoint or the coatings, because all the coating requires is that scratch.
So in your opinion, would a planetary give you the same benefits as a direct drive?
From the perspective of scratching it?
Yes, from creating
Yes.
a profile, whether you need a deeper profile for a thicker mill system or a thinner profile for a thin mill system. Is there any difference between the results a planetary will give you versus a direct drive? Are there any value propositions of one over the other versus speed or use of diamonds or anything like that? What I'm trying to get at, Josh, is if I'm a contractor looking to make my first purchase, there's a lot of discussion out there, planetary action versus a direct drive. Based on what I want to do as a contractor, should I be looking at one of those technologies over another?
When it comes to scratching the concrete, and I think I understand what you're asking. When it comes to scratching the concrete, it doesn't matter what I use. The floor will tell me if I've scratched it or not. That could, like I said, it could be a hand grinder. When it comes to the style of the machine, though, whether it be a rotary or a planetary or, as I said, a hand grinder, it's going to be a matter of, one, what kind of production do I need? Based on the size of the crew that I might have for how many square feet I need to produce in a day. And this is what I also offer to anyone wondering what size machine to get, is how many square feet I need to have prepared in a day. Because there's machines out there that'll do a couple thousand feet an hour that are large, big machines. Then there's ones that only do 400 or 500 feet an hour. When it comes to the correct machine that I should be buying or should be considering, it's going to depend on how many square feet do I need to get done in a shift. The second thing that's important, and this is where there is a difference between the different models, is the way that the rotary versus a planetary operates. A rotary, sometimes called a very old design, it is an old design, but it's also very durable. It is a motor that's over the top of the gearbox with a direct drive shaft that goes to the helical gears inside the gearbox. That means there's no belts, there's no chains. It's a very basic system, though, meaning it turns the diamonds in one rotation. If there's two heads, one goes clockwise, one goes counterclockwise. Very basic. But that very basic design lends to the reliability and the durability of the machine, which means when I turn it on, and if I hit something, it's very unlikely that I'm going to do any damage that can't be fixed on the job. It also means that there's really no maintenance required for steel gear to steel gear interaction for thousands of hours. When it comes to a planetary, also good design and dependable, except it requires, in order for the motion of the heads, and that's what the planetary, that's where it gets its name, it requires belts and chains. There's plenty of people who are successful with planetary machines and will continue to buy them because they serve them well. But the fact remains that a rotary with steel gear to steel gear operation inside the gearbox, sealed gearbox, is going to outrun a planetary when it comes time to do regular maintenance on that planetary machine, because those belts and chains in time do have to be adjusted and they do have to be replaced. The steel gear to steel gear design, unless something catastrophic happens, or if for some reason it was to get water inside it, which is possible from change of seasons over enough years, if not decades, there may need to be some maintenance. But the primary difference is what keeps the rotary running, when the planetary at some point will have to be broken open to change out those parts that are expected to wear or eventually break.
Going down that planetary rabbit hole, talk a little bit about passive versus active. I hear those terms a lot in the field. I know the mechanical action is similar, but there's a very distinct difference between a passive planetary and an active planetary.
I'm not real clear on the exact mechanics of it, but basically, in the simplest terms, a planetary has, let's just say a standard machine would have 9 tools on it, which means 3 heads. Those 3 individual heads on a passive planetary will turn, but the main drum that they're attached to is floating because it's passive. So that basically means the machine, as it's turning, those heads are turning, and as they do, the main drum will maybe turn or maybe not. The alternative to that is the opposite, meaning the drum may be turning, but the head's not. So passive basically means one of the pieces on the bottom of the machine, or one component on the bottom of the machine, is driven to rotate, and the others follow suit by floating or counter pressure. Let's say they will be encouraged to turn, but it doesn't mean they will. It just means that they are able to rotate as the main gear or the individual heads are turning. When it comes to a driven, both the main gear as well as the individual diamond heads are turning. So that means it's got more power input, but also the ability to be more aggressive. It basically means that this main drum on the machine is being propelled by the motor, and then the individual heads themselves are also being turned separately. That is something that gives the operator a lot more power, a lot more cut to the floor. But some of the manufacturers make it so that each of those can be independently controlled. So now it's possible to dial in the speed of the main gear and the speed of the diamond heads. And then, of course, that allows for many possibilities of combinations of speeds. And there is something to that science as well, which is beyond me. But that's the primary difference. One is forced to turn, both the diamonds and the main drum. And the other one is one or the other is forced, and the other one just follows suit as the work continues. So it's, if it wants to not rotate as much or gets hung up for whatever reason, undulations in the floor, it just won't. And sometimes that happens too.
Speaking of undulations in the floor, if I have a floor, most floors, as we know, are not flat unless they're designed specifically to be that way. There's some sort of undulation, bird bass, almost in every floor. Will a grinder, if it's skimming across the surface, will it hit those bird bass? Can it grind down the high spots? Can I do anything as a contractor to manipulate my machine to do one or the other, either go grind flat or to follow the undulation? Talk a little bit about what your options are as a contractor. Is that specifically within the grinder itself, or are there things I can do to my grinder to make it either grind flat or follow the undulation?
It's going to depend on the nature of the undulation. You know, how much the floor deflects or how much it may rise. If it's severe enough or abrupt enough, then on a rise, the machine could certainly, almost like a mountaintop, could be perched on top of that peak and it could attack it and mow that down. The bigger problem, the more frustrating issue, is when there's a deflection in the surface of the concrete. Now, depending on how wide that bird bath, as you call it, may be, then it's possible the whole grinder will follow down into the bird bath and still profile everything. We're not really, unless it's specified, we're not too worried about floor flatness when we're grinding. It's just for the purpose, again, of scratching everything. However, there are sometimes from the troweling process where there will be a 3 to 4 inch wide circle or depression in the floor for whatever reason. And as the grinder passes over it, neither model is going to really be able to go down inside that low spot and profile that. In most cases, the floor around it has to be cut down to the lowest point in that deflection in order to grind it to the same color as the surrounding concrete that's being scratched. The way to sometimes fix that problem is if I'm doing cross cutting, or maybe I'm forced to do cross cutting, regardless of the model, then I'm going to be cutting maybe north, south, and then east, west. And the reason is try to attack that deflection or that rise from two different directions. There's really no way, unfortunately, to know that until the floor is being ground, unless those deflections and those rises are severe enough that they could be seen on a walkthrough. I have heard people say that a planetary cuts more flat and a rotary follows the floor better. And I've heard exactly the opposite. So I don't know that I would say one or the other is true. It's very subjective as it relates to the floor it's being cut. If a floor has deflections and has rises in the slab, if the severity of them are within a range, the grinder may not even show it. You may just feel the machine going up and down as it goes over a non-flat surface. But those deflections in the floor, both machines could struggle with that too. So I will say that these days, it seems to me, a lot of the planetary manufacturers have come up with coupling systems, some flexible additions that allow their machines to follow the contour of the floor a little better, where traditionally they didn't. But nowadays, it seems a lot of them are. The rotary design has always had a flexible coupling system on them that did more often than not want to follow the surface of the concrete, as opposed to staying rigid and skipping across from high spot to high spot.
This concludes episode 2 in a series of podcasts focusing on basic principles of concrete surface preparation. Make sure to join us for episode 3, where we begin our discussion with wet versus dry and migrate the conversation to specific mechanical surface preparation processes. For immediate access to hundreds of industry tutorials and product demonstration videos, we invite you to visit the By Manufacturers Direct YouTube channel. Simply visit the By Manufacturers Direct homepage and click Watch More Videos. New videos are added weekly, so don't forget to subscribe and click the bell icon to be notified when we post a new video.